All right, so in example 1 for section 8.4, a student is interested in determining if there are gender differences in texting while driving. She collects data from a random sample of 80 men and 60 women. Of the 80 men, 38 reported they had texted while driving. Of the 60 women, 27 reported that they had texted while driving. Assume the samples were random and independent. Can the student conclude that the proportion of men and women who text when driving are different? Use a significance level of 5%. All right, so we're told here to let P1 be our proportion of men who texted and P2 be our proportion of women, just to make things a little more straightforward. All right, so our population that both of these samples are being drawn from are all drivers. All right, N1, our sample 1, is going to come from the men. So there were 80 men surveyed. Our P1 is going to come from our 38 divided by 80, which is going to give us 0.475. All right, and then our other sample, there were 60 women sampled. And our P hat 2 is 27 out of 60, which gives us 0.45. Okay. Now, for this P hat without any subscripts, remember this is an average of our two different proportions. So we're going to take x1 plus x2 divided by n1 plus n2. That was that little formula that I boxed off on the first page of this section. All right, so x1 plus x2 are a number of successes. So in this case, it's our 38 plus 27, and then we're going to divide it by 80 plus 60, right, which gives us 65 over 140, which turns out to be 0.464, or 46.4%. It's somewhere in between, which should be expected. Our level of significance, alpha equals 0.05. What we want to know, are the proportions different? Right, so we weren't told specifically if we were looking for a greater than or less than case. So if we're just asked if they're different, that is a not equal to case. All right, so our hypotheses. Our null and alternative hypothesis, remember that these both have P1 and P2. So our null hypothesis is always that P1 equals P2. And in this case, our alternative hypothesis is simply that P1 does not equal P2. If we do have a greater than or less than, we do need to pay attention to that. All right, so now we're going to check our conditions. We are going to go through it in this particular problem. So first we're looking for our first sample, our proportion of men. The sample is random and independent. Yes, we're going to assume that that's true. Our number of successes, 80 times, notice that we're using our plain P hat. So we're using this 0.464. Okay, that's 37. 80 times 1 minus 0.464 is 43. Large population, all drivers greater than or equal to 10 times 80, which is 800. We can assume that this is true. All right, now we're going to check our condition for our other sample. All right, so our proportion of women, our sample is random and independent. We're going to assume that that's true. 10 successes, so we're taking, this time our sample size is 60. We're still using that 0.464. So it again is just our P hat. All right, and we're taking 60 times 1 minus 0.464, which gives us 31. We're going to assume that there are more than 10 times 60, which is 600 drivers. All right, so our conditions are checked and we are good to go. All right, so now here's where it comes time to put our information into StatCrunch. So as we are plugging this into StatCrunch, we are going to go back to our original information that was given in our problem. Right? So we want to be sure to use the observed values for our number of successes. So when we're doing that, right, our observed value, our x1 was 38 and our n1 was 80. That was our population of, or from, not our population, our sample of men. X2 was 27, N2 was 60. All right, that was from the women. So those are going to be the numbers that we're going to use in StatCrunch. So again, as we're entering these in, make sure you're getting everything in there correctly. Make sure, again, when we're looking at the bottom part, we don't need to put in any numbers. We don't need to change that 0. We just need to make sure that we check the correct inequality symbol, which in this case is a not equal to. Okay, so our z we get is 0.29. Our p-value that we get is 0.77. Right, so if we compare these, 0.77 is our p-value, 0.05 is our significance level. This is clearly larger. So our p-value is larger than alpha. That means we are going to not reject our null hypothesis. So going back to our previous page, all right, here we have our hypotheses. We are not going to reject our null hypothesis. So that one gets circled. Our alternative hypothesis gets crossed off. So our final interpretation here, we cannot conclude there is a difference in the proportions of men and women who text when driving. So again, by checking all of our conditions, it is a slightly longer process. We need to make sure that we are going through and putting all of the pieces in there correctly, entering into StatCrunch correctly, and then in this case we do not reject our null hypothesis because our p-value is larger than alpha, so we cannot conclude there is a difference in the proportions between men and women who text when driving.